Hey, Vsauce, Michael here.
Oh. Hey.
Boring! Welcome to our technology disaster video. In this episode, we will be discussing the physics of iPhone bending.
Following the release of the new iPhone 6s, many users have complained that their screens have started to bend. This video will try to pinpoint the various factors which contribute to this issue.
In physics, a force is something that changes the motion of an object. Observe. As we will see, where the force is applied can change its effect on an object greatly. Pressure is the force placed on an object divided by the contact area. As the contact area increases, the pressure on the object decreases. Hold on. This effect is demonstrated by snowshoes. If you step your normal foot into the snow, it will break the surface area, and you'll easily push down into the snow. But if you use better tactics and use a wide snowshoe, which looks like a tennis racket, it will increase the contact area of the force, and you'll be able to tap on the surface of the snow, and the pressure will be decreased. Torque is the linear twist of an object. It is the rotational equivalent of a linear force, as we noted earlier. Where's Parker? I'm right here, guys. Torque is demonstrated by opening a door or pushing on a whiteboard. If I push on a point further from the hinge, it's easy to open and it takes less force. But if I push closer to the hinge, it doesn't go as far, demonstrating that it requires more force to push at the same distance.
We believe torque was a more likely cause of the iPhone bending because even if force were to be applied, the direct force would not cause the iPhone to actually bend. We will investigate how the torque would have caused the iPhone to bend through this model right here.
You are so stupid.
Oh, wrong direction. Here we have a diagram which simulates the position of the iPhone when it is getting bent. The gray represents the iPhone, the blue represents the jeans, and the purple is the leg. This diagram shows the actual forces involved in this scenario. There is a normal force as the phone is against the leg and a tension force that is being applied against the phone. These diagrams show how the torque is present during this scenario. Torque can be measured using the following equation as shown on the screen. R is the distance from the edge to the center of the phone. T is the tension of the pant. All of that multiplied by the sine value of the angle of the jeans. The first diagram here shows how all three variables are at play, conveying the idea that torque is more likely to cause the bending of the iPhone. We will now show a sample calculation in order to calculate the torque. Step 1. Draw a free body diagram. This is the same diagram shown previously in the video. Step 2. Find the appropriate equation for the problem. Since we are finding the torque, we shall use the equation that was mentioned earlier. Step 3. Define the variables. For the R value, we can put the distance of the iPhone 6 Plus from the edge to the center to be about 7.9 centimeters or 0.079 meters. The tension, according to Levi Jeans, is said to be about 142 pounds, which is about 632 newtons. And the angle of the jeans can be estimated to be about 10 degrees. Step 4. Plug all the values into the equation to get the torque. The final answer is negative 27 Newton meters. According to a few articles, a negative torque denotes that the object is rotating clockwise.